Welcome. Today I'm going to talk to you guys about our first topic in the second unit, the real first unit in physics, if you will, and that is on position. Now this is going to be very simple, it's going to be very straightforward, and so we're going to get right to it, no big deal. So I want to welcome you to our video here. It's 007 on position, no big deal. As I said, there are just a couple of little things that you want to remember as a result of this. So let's take a look at it. First, how do I report where something is? Well, this is actually a little bit trickier than it sounds. You may never really have thought about this particular issue before, but it's something that comes up in physics early on. And the more you think about it initially, the better off you're going to be later on for how you analyze motion. So let's take a look at that here real quick. I'm going to draw just a little bit. Okay, so here's the situation. So let's imagine for a moment that here's the ground, the earth. This is maybe a rock that's sitting there, and then you've got an object. So let's say we have a toy car. Okay, so there's this little toy car that's right here, like so, just sitting there, not doing anything. And then overhead, you've got a toy airplane, like so. There we go. So you've got those two objects there, three objects if you include the rock. But the other two you can imagine might actually move. And so the question that I would ask you is, how can we tell? How can we describe to you guys where things are located? Well, if I say the car is right there, that's not really a very scientific way of doing things. And if I were to try to describe that to somebody else, I would really have to have some sort of a reference point away from which I'm going to measure. So if I determine that this rock is my reference point here, so this is my reference point. Now, when you think of a reference point, I immediately want you to think about a set of axes. So you guys have dealt with axes before, right? So you've got a y-axis, and you've got an x-axis, like so, like that. So this is your y-axis, and this is your x-axis. And the origin for that is right here at this rock. And who decided that? I did. You can really decide wherever you want. But it's convenient here because I'm able to then measure the distance that the car, the little toy car, is away from that rock. And then if somebody asks me, hey, where's the car? I can say it's this distance away from the rock. So hopefully that makes sense to you guys. So I've picked my reference point, and now I'm going to go ahead and make some sort of a measurement. So I'm going to line up my meter sticks here, and I'm going to measure the distance that it is away from that rock. And so let's say this is 1 meter here, this is 2 meters here, this is 3 meters there. So 1, 2, 3. So my description of the position there could be that, it doesn't have to be, but it could be that the car is about let's say 3 1/3 meters. So let's say this is 3.3 meters to the right of the rock, which I decided was the reference point. To the right. Right. There we go. I usually circle my directions so you know that there are actually directions there. So 3.3 meters to the right. I estimated that last digit there, so obviously you'd be much more precise in your measurements than I'm doing with this simple drawing here. Now, could I have picked a different location? Certainly. I could have picked, let's say there's also, I didn't know it before, but let's say there's also a bug right here. A little insect. Insects have 6 legs, so I have to draw all 6 there. So you know it's a bug. There we go. There it is. So I could have used that bug as my reference point. What would be one of the reasons why I wouldn't? well, bugs tend to move, right? And so you want a reference point that's going to be stationary enough that you can refer back to it later on if you need to. Um, so hopefully that makes sense. Now the other object in this setup right here is the airplane. And so I could, if I wanted to, go ahead and describe where the airplane is located. Now, typically in this case, I'm gonna go ahead and describe how high up it is. So I'm gonna, instead of using the rock as a reference point, I'm gonna choose to use the ground. Most people typically, when they're talking about how high up something is, will just go ahead and reference the ground. They may not even actually tell you that they're referencing the ground, but it is in fact what they are doing. So the reference point in this case would be the ground. It happens to be that the rock is on the ground, so we can use the same reference point. Then I would go ahead and measure the distance that it is above the ground up to that height, and I would be able to tell you in the y dimension that, let's say this is, let's see, here's 1, 2, and let's see, this is exactly 3, just to make things easy. 3 meters above. There we go. So here I have the car is 3.3 meters to the right of the rock, and here I have that the toy airplane is 3 meters above the ground. So that's how I can indicate where a position is. Notice that there's two parts to each description. There's the actual distance measurement, and then there's the direction measurement. And you need both to be able to accurately describe where things are located. Why? Because if I'm going to tell somebody the toy airplane is 3 meters, you're going to assume, hopefully, that it's 3 meters above the ground, but I wouldn't necessarily believe that that's true. It could be 3 meters above, let's say, the surface that you're standing on, and the surface itself might be, let's say, a different distance above the ground. So oftentimes we'll assume that it's the ground, but it's not necessarily always the case. Okay, so hopefully that makes sense. You can see why you need to go ahead and come up with some sort of a reference point there. Now, it's totally up to you what reference point you pick. Again, you definitely want to pick something that's obvious, something that you can reproduce, and something that's not going to move on its own. So going back to that situation before, if I have the rock here and I have the bug here, right? Obviously, if I'm going to compare which one I'm going to measure against, the rock has a very low probability of moving, and so it's probably going to be stationary with respect to the ground or with respect to any observer, whereas the bug has a pretty high probability of moving around. So obviously I don't want to pick the bug. Also, I could pick, let's imagine for a minute that we're trying to measure the distance or the position of the bug. So if I pick the rock as a reference point there, I'm going to call it reference point 1, I can measure the distance that the bug is away to the right from that reference point. Could I also, though, determine, let's say there's a rock over here as well. So could I pick that the reference point is here and tell you that the bug is instead this distance to the left? I totally could. It doesn't matter at all which one you pick. However, it tends to be the case, as you might remember from your elementary science or math classes, that we have a number line, and in the number line, the reference point tends to be 0. And then any number to the left is going to be negative, and any number to the right is going to be positive. So you can already start to think that there's going to be one of these reference points that's going to make your life a little bit easier. For me, because I find negative numbers to be troublesome and to cause problems with remembering that there's a negative in there, if I'm going to choose one of these two, I'm going to pick the one that makes the distance positive and not the one that makes the distance negative, because that would be a problem. Now, I could, if I really wanted to, and this would be kind of crazy, but I could go ahead and turn this whole number line over so that positive was going to the left and negative was going to the right. But let's keep things as simple as possible. The same thing could happen with distances upward, right? So let's imagine for a moment here that we have a number line that's going this way instead. That's a vertical number line. It's totally okay to have a vertical number line. Typically up would be positive and down would be negative. So that's important to remember. Now, is that going to come up in the class? Absolutely. So let's imagine for a moment that we have, in this case, an object, let's say a water balloon. Okay, so here's our water balloon. Okay, and somebody has thrown it or is throwing it. So I'll go ahead and draw our person who's throwing it. I often talk about water balloons because I think they're pretty cool. So there's our person who's throwing it. So we could determine that the water balloon starts at a position that is at a 0 line, like so. And then as it moves, either upward or downward, we could describe its position away from where it started. So that would be one choice of reference point. Now notice that downward tends to be negative, and so that's important to remember because we're going to do a lot with falling objects, which means we're going to do a lot with things that are falling into the negative direction there. So we want to make sure that we're careful about how we do that. Again, the goal is to pick a reference point that makes your math easier. Picking this as the 0 point is not a bad idea. If you pick the ground as a 0 point, then you're already starting at some positive number, and so you have to keep track of that initial starting point as a positive above the ground, and sometimes that gets a little confusing. Okay, last slide. So what is the position variable? Easy enough. We're going to go ahead and talk about that here real quick. It's not going to be any surprise to you, I hope, that for this class, we are going to use, for horizontal positions, we'll use an X position variable. For vertical positions, we're going to use a Y. Now notice I draw them in kind of cursive, so people kind of find that confusing sometimes. Just be careful with it. Now, one of the other things that you might come up with, and you might see in here, is that there are other variables that might go along with these. So I'm going to go ahead and talk about those here real quick. This one, the position, you might actually see somebody write as a distance. And so, like, for example, one of the other physics teachers always deals with distance rather than position. So they use a little d for that. That's totally okay. It's fine. It means roughly the same thing. I use x because that's what they use in your math classes. And so that's why I want to try to keep it as consistent as I possibly can for you. I'm trying to do you a favor. I use y for vertical, again, because they try to do it in your math classes. However, because we're talking about distances potentially above the ground, you could have a height in there as well. And so you may see that. You may see a height up there. You may also see an altitude, although I don't ever use the A for altitude, so don't worry about that. You'll never see that. You will see height, though, so you want to make sure that that's something you remember. Typically, a height has to be positive, so the height assumes that the ground is your reference point. So you can only use that in certain circumstances, unless you specifically say it's a height above the table or a height above the ceiling or something like that. Anyway, so those are the two types of variables that you're going to see. Now, if you're in calculus, this is one little side note. Again, if you're not in calculus, you can just tune me out. Totally okay. But if you're in calculus, you may see an S for position, and that's totally okay. Same thing here. Not anything you need to worry about too much. Okay. Okay. Real quick, we're done. Excellent. Nice job. So thanks for watching. If you have a few minutes, I need you to go ahead and fill out your quick note sheet and then your interesting question form. As we're getting into the meat of our physics class, we want to make sure that we are relying pretty heavily on this interesting question form to drive our discussions. So it's crucial that you guys spend a little bit of time thinking about what questions you have. Hopefully that makes sense. If you have any further questions, you can go ahead and ask them in our discussion that we'll have on the next day after this video. You I would highly encourage you to use the interesting question form to frame those questions. However, if you have too many questions, you're certainly welcome to bring them in. Also, because we're getting into the meat of things and things are getting a little more complicated, I would highly recommend that you think about emailing me if you have any questions. I try to, as best I can, I try to respond to emails, excuse me, if they're sent to me before like 7 or 7:30. Remember, I'm kind of old, so I try to go to bed a little bit earlier. I get up pretty early to get to school. So anyway, sorry about that. All right. If you have any questions, let me know. Thanks.